So in our first exam style question, we're just going to state Boyle's law, making it clear what any symbols we use refer to. So Boyle's law states that for a fixed mass of gas at constant temperature, P times V is constant, where P is the pressure of the gas and V is its volume. So there we've very clearly stated what Boyle's law is, and we've also said very clearly what our constants are too. Then we've just got one quick question here, which is that a small pump is connected to a larger container with volumes and pressures as shown below. The pump is then used to push all the gas inside it into the larger container through a valve, so the smallest pump is now empty. Assume the temperature is unchanged after this process. So what is the new pressure of the gas? So the first thing to note is that this is definitely Boyle's law, because we've got a volume changing but a temperature remaining constant. The other thing to note is that I've actually labelled that the pressures in both of these things are 105 kilopascals, which is 105 times 10 to the 3 newtons per metre squared. But I don't really need to do that because we've said that they're connected by this tube. And we're going to assume that air was flowing through freely before we decided to push all the gas outside of this small pump into the larger container. So they're connected, which means that the pressure must have equalised between the two of them. You can now have something's connected and gas can flow between the two. It will always be the case that the gas will come to equilibrium, equilibrium pressure. That is to say that we'll reach the same pressure in both of them. If there's any way for gas to get through, that will happen eventually. So that's what we've got here. They're at the same pressure, and this is a bigger volume and that's a bigger volume. What happens is originally air's in both of them, and then what happens is that all the air here is pushed out of this. There's some, I don't know, pump on it or something. It's all pumped and all this air leaves and goes through into here. And then this is now empty. And so then we've got to work out what the pressure is inside this new container, because it's not going to be this anymore. This is our original pressure, which we're going to label P1. So this is a bit confusing because before we've just talked about having one volume, which we then change we have one container, we change the volume of, and then we see what happens to the pressure after that, or vice versa. But here we've got these two volumes, and then we're just left with one volume and what's going on. The answer is that really we just pretend this was all one volume. So we say that our V1 is just going to be equal to the sum of these two volumes to begin with, because that's the volume of gas we have. Even if it's not all in the same container, it's all connected, so the pressure is the same everywhere. So that's how much gas we have in the first place. So it's 7 times 10 to the minus 4 meters cubed plus this one here, which is 3 times 10 to the minus 4 meter cubed. And our original pressure, P1, is 105 kilopascals. And this is where we use Boyle's law, that PV is constant. So you must have P1 V1 is constant. Or rather the PV is constant, that is to say, which means that when we have our P2 V2...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.